Topics to be covered in this video is Introduction to Embedded C, Embedded System hardware, Embedded System versus personal computer, C versus Embedded C, Embedded System applications, Embedded System design parameters, device drivers, Embedded System developers, characteristics of embedded system, types of embedded system, advantage of embedded system, and disadvantage of embedded system. Introduction to Embedded C. In the fast-growing market of embedded systems, there is an increasing need to write application programs in high-level language such as C. Basically, there are two reasons to develop these trends. Programs for embedded system become more complex and hence are difficult to maintain in assembly language. Processor models for embedded systems have a decreasing lifespan, which implies more frequent readapting of applications to new instruction set. The code reusability achieved by C-level programming is considered to be a major step forward in addressing this issue. Let's start with the Embedded C. Embedded C is a set of language extensions for the C programming language developed by the C Standard Committee to address commonly issues that exist between C extensions for different embedded systems. Embedded C use most of the syntax and semantics of C, such as main function, variable definition, data type declaration, conditional statement, loops, function, arrays and string, structure, bit operation, etc. Point to remember: C extensions and embedded C. What is an embedded system? An embedded system is a combination of computer hardware and software, fixed in capability or programmable, designed for a specific function or functions within a larger system. Industrial machine, agricultural and process industry device, automobiles, medical equipment, cameras are possible locations for an embedded system. Basically, embedded system C does not exist as a language. It is simply C with some library built in C around the type of hardware you are using for the development purpose. Points to remember here: computer hardware and software. Libraries built in C. Next topic is embedded system hardware. Embedded system hardware can be microprocessor based or microcontroller based. In either case, an integrated circuit is at the heart of the product that is generally designed to carry out computation for real-time operation. While the microprocessor only implement a central processing unit and thus require the addition of other components such as memory chips, whereas microcontrollers are designed as self-contained system. Microcontroller includes not only a CPU but also memory and peripherals such as flash memory, RAM or serial communication port. Microcontrollers tend to implement full low computer power system. For example, microcontrollers are used in the operation of vehicles, robots, medical devices and home appliances. It is present in almost every electronics devices. In military application, guiding missile, detecting aircrafts, satellites. Each embedded system is unique. Hardware is highly specialized to the application domain. There are quite a lot of software that allows you to use embedded C. AVR Studio for AVR controllers, Micro C for PIC controllers, Arduino software for Arduino development boards, IDE Kill for ARM. Next topic is embedded system versus personal computer. How a general purpose computer is different from embedded system. The difference between a PC and an embedded system can be summarized on the basis of purpose, constraints, performance, user interface. Purpose. unlike GPC, which are built to be customizable in software and can be used for multi-purpose. An embedded system is rather simplified and built to serve a dedicated purpose, that is single function. Constraints. Usually embedded system comes with tight resources, that is power, memory, cost, real-time, size constraint. GPC are comparatively richer in resource and they might face cost and average speed as their constraints. Performance. Embedded system is built for fixed runtime requirements. In case of GPC, they are much faster and the performance is much better than embedded system. User interface. The user interface for embedded system is not limited to traditional interface like keyboard, mouse and touchscreen, which generally there are GPC. Mostly the user interface in embedded system is integrated into a real world. It carries input-output port such as button sensors for input, actuators and stepper motor for output. Next topics. C versus embedded C. C is generally used for desktop computer, while embedded C is used for microcontroller based applications. C can use the resource of desktop PC like memory, OS, etc. While embedded C has to use with limited resources such as RAM, ROM, input-output on an embedded processor. Embedded C includes extra feature over C such as fixed point types, multiple memory areas, input-output register mapping. Compilers for ANSI C typically generates OS-dependent executables. Embedded C requires compilers to create file to be downloaded to the microcontroller, microprocessor where it needs to run. These are the few embedded system examples. Some real-life applications of embedded system are as follows. It is used in consumer electronics, household appliances like washing machine, microwave oven, air conditioner, medical equipment, industrial applications, aerospace, communication, and so on. Examples of embedded system in automobile, that is for fuel injection systems, anti-locking braking system, music and entertainment system, controls for air conditioner. What is an embedded system design? A system design with the embedding of hardware and software together for a specific function with a larger area is embedded system design. In embedded system design, a microcontroller plays a vital role. Microcontroller is an important component of an embedded system. External processor, internal memory, and input-output components are interfaced with the microcontroller. It occupies less area, less power consumptions. Following are the design parameters of an embedded system. First one, power dissipation. Always maintain low. Performance should be high. Process deadlines. The process should be completed within a specified time. Manufacturing cost should be maintained. Engineering cost. It is the cost for the test, edit, debug of hardware and software. Size. Size is defined in terms of memory, such as RAM, ROM, flash memory, physical memory. Prototype. It is the total time taken for developing a system and testing it. Safety. System safety should be taken like phone locking. User safety like engine braking oil, breaking down safety measures must be taken. Maintenance. Proper maintenance of the system must be taken in order to avoid system failure. What is the role of device driver in embedded system? The device driver are embedded software modules that contains the functionality to operate the individual hardware devices. The reason for the device driver software is to remove the need for the application to know how to control each piece of hardware. Each individual device driver would typically need to know only how to control its hardware device. For instance, for a microwave oven, separate device driver control the keypad, display, temperature, and radiation control. Next topic, embedded software developer. This application developer typically do not have any interaction with the hardware. When designed properly, the hardware device drivers are abstracted away from the actual hardware so that the developer writing software at the application level does not know what will be getting in output. What are the roles of embedded software developer? Must retain with the hardware knowledge. Developer has to write efficient code. Developers should have knowledge of peripheral interfaces. Developers should design the robust code. Developers should use minimum resources. Code probability or code reuse. Writing software so that it can be moved from one hardware platform to another hardware platform. Developer need to learn new development tools, debugging tools, and different integrated development environment in circuit emulators. Next topic, characteristics of embedded system. These are the various characteristics of embedded system, that is task specific, time specific, minimal user interface, high efficiency, high reliability, highly stable, requires less power, low cost. Embedded system generally used for do specific task. It provides high reliability and real-time computational ability. It requires less power to operate. It can be used to design low-cost applications. Next topic is types of embedded system. Based on parameters, embedded systems can be classified into two broad categories. On the basis of performance and functional requirement, it is categorized as real-time embedded system, standalone embedded system, network embedded system, mobile embedded system. On the basis of performance of microcontroller, it is categorized as small-scale embedded system, medium-scale embedded system, sophisticated embedded system. Next topic, advantage of embedded system. Embedded systems are convenient, mass production, low price per piece, highly stable, reliable, made for specific tasks, very small in size. Systems are fast and also used. Next, disadvantages of embedded system. Once configured, this system cannot be changed, hard to maintain, difficult to take a backup, troubleshooting is difficult, and hardware is limited. These are the few references are used to create this video. In this way, today we have learned the topic Introduction to Embedded C Part 1. Thanks for watching this video.